Hi, everybody. All right, so last time we talked about food chains and food webs. And now we're going to look at a food chain in a slightly different way. So if we look at a food chain, right, we've got our producers. Those are the plants that are able to trap energy and put it into compounds like sugar. And then we have primary consumers that eat those plants, and then secondary consumers that eat the primary consumers, and higher order consumers, right? And each step of the way, the arrow represents energy and atoms moving from one organism to the next through the ecosystem. That's our food chain. But what's interesting is that each of these organisms does stuff. The plant moves materials around their body. They do active transport to move stuff. Insects do active transport. They hop. They think, sort of. They don't have teeny tiny brains, but they do a little bit of thinking, right? And mice are running around, and they're smart enough to try to get away from owls and try to chase insects and so forth, right? So each of these things does stuff. Now, the atoms that came into their bodies, they stay atoms, and their atoms are still there. They may exhale them, they may pee them, they may poop them, but the atoms themselves are going in and out at about the same rate. So they're made of some atoms, and those atoms are available to the next step. But the energy is getting used to do stuff, and it released as heat. And so each step of the way, the number of atoms stays about the same, but the amount of energy goes down because it's used for life processes. That's why you have to have a constant supply of energy into the plant, because it gets used up. You can't recycle it. The atoms can be recycled, so you don't need like atoms pouring in from heaven to come onto the planet and be there for plants every day, because we can recycle them. Decomposers can recycle them. But the energy is used up all the way, so thank goodness there's a sun that just keeps pouring energy down from the sky. Okay. So because the amount of energy goes down every step of the way, if you look at all the energy that is available in all of the producers in an ecosystem, they're going to have more energy than if you took all of the crickets in that ecosystem, in that food chain, in that area. The crickets would have less energy, because while there was a whole bunch of energy trapped in these plants used some of it. So some of it's not available to go up to the next step. Same with these crickets. Once the energy that did go into their bodies is there, they hop around. Not all that energy is available when the mice eat them. And so there's less energy for the mice. And the mice run around, so energy gets used up there, so there's less owls. So as you move up a food chain in an ecosystem, there should be fewer and fewer of those organisms. Now, not necessarily the number of organisms, but the total. Like if you took all of the energy in all of the owls, that would be less than all of the energy in all the mice. And that would be less energy than all the energy that would be in all the crickets. So as you move through the food chain within an ecosystem, the amount of energy decreases. And so you can present it in a pyramid. The producers take up the biggest chunk. But as you move up the food chain, when you get to the top of the triangle, the pyramid, you have very little energy. Very little energy at the top, lots of energy down at the bottom. Here's an example of one. All the producers, the primary consumers, the bunnies that eat them, the secondary consumers that eat the primary consumers, and the higher order consumers. As you go up, you're going to have fewer and fewer. So if you go out into a field, you're going to have tons of plants, but you're not going to have as many bunnies as you do plants. Even you're not going to have as much if you put them on a scale and weighed them, right? There'd just be less bunny matter in the ecosystem. And there's fewer snakes and very, very few of the hunters. And this kind of makes sense. I mean, if you just think about it, imagine that there were more bunnies than there were plants. Well, the bunnies would eat all the plants, and then they'd have no food, and then they'd die, right? Let's say there were 10,000 snakes and one bunny. Not going to work. You need more bunnies than there are snakes. So the snakes have food and the bunnies can reproduce. Because if the snakes eat all the bunnies, there won't be any bunnies to reproduce, and then the snakes will die too. So the whole food chain collapses unless there's more plants than there are primary consumers. And there's more primary consumers than there are secondary consumers. And there's more secondary consumers than there are higher order consumers, which is why when you go to the field, you may have tons of plants and a couple of bunnies, but you are not going to have tons of hawks living in the area. You might have one, because that's all the area can support. And that is the energy pyramid in an ecosystem.